This is week 4, and we're going to review today the first half of math. I'm going to do two things. I have some examples, and then we'll go over the classwork quickly and see if there's any questions. So everything that I'm showing you now in these examples should look at least somewhat familiar if you've been keeping up with your work. What is the slope and y-intercept of this linear equation? Well, we've done a lot with geometry as it relates to the coordinate system, so let's take a look at that. So on number 1, slope and intercept. Well, the first thing is not y equals, so I would divide by 3, divide by 3, and divide by 3. And the new equation I would have is y equals 4x plus 2/3. And once it is y equals, what you see is what you get. So the starting point, the y-intercept is 0 2/3. So that y-intercept is right there somewhere. The slope is 4. That's a steep line. I go up 4, 1, 2, 3, 4, and over 1. And if I want to graph the line, it would look like this. But there's the answers to those problems. The key to it is looking at the slope-intercept, making it y equals. Number 2 is also asking questions about a graph, but it's different. If it's asking for the center and radius, it must be a circle. And this one's in graphic form. If you remember the completed square, the quantity squared, you always take the opposite. So the center is not 5, but -5. Not -1, but +1. So at -5, 1 would be the center of that circle. What is the radius? It's the square root of what it equals. Square root of 25, which they were all that equal, is 5. So from that point, you would go right 5, left 5, down 5, and up 5, and out 5 if I was actually wanting to graph, and that gives you a pretty fair circle freehanding. So the first two was looking at the coordinate system of things we've done in the past, lines and circles. It looks a little different on the coordinate system, but it's something that's very common used. I can't imagine you next year taking the ACT or the SAT or taking a course without having questions like this. Questions there? You still good, Brad?
Still good.
It looks like we have one question. Eve, go ahead.
How did you get the 5 again?
The 5, once you have completed squares, that's a completed square, and this is a completed square. Whatever the number it equals, it's the square root of that. It comes from the Pythagorean theorem. In other words, a squared plus b squared equals a hypotenuse squared. But in this case, it's not the hypotenuse, it's the radius. So it's the radius squared. And I know 25 is 5 squared. Now, Eve, they don't always come out even. In other words, it could be a 10. Well, the square root of 10 is around 3, so it's going to look like it's 3 when you graph it. So this would come out nice. Good question. Any other questions before we go on? Well, there's a couple things we've done in the past. Question 3. What is the area of a right triangle with sides of 10, 24, and 26? Well, I would draw that. The large side is going to be the hypotenuse. So I'm going to say that represents 26. Now, if I had coordinate points, I'd have to use the distance formula. We'll do one of those here in a second. One of the sides is 10. We'll say that one's 10. And the other one is 24. Well, if you remember from grade school and middle school, the area of a triangle equals 1/2 base times height. This is the base, and 10 is the height. So I'd put those numbers in. I'd say 1/2, 24 times 10. Half of 24 is 12. 12 times 10 is 120 units squared. Now, if I did this on the coordinate system, I would have made the origin the vertex, and this would have been a 24, 0, and I would have plotted the points. And I could have actually counted the actual squares, and believe it or not, there would be 120. Questions there on number 3, the area of a right triangle. Sorry for the misspell. Beth, you'll get a kick out of this one. The other day I was do the slope. Apparently I didn't hit the E. Do the slop. I thought it was someone here. Miss Brad thinks it's someone here. Don't make me tell the potato joke again, Beth. Don't make me. Don't make me. I will.
Probably don't have to make you. It's probably coming.
Thanks, Brad. Brad hasn't been
You're welcome.
2 or 3 years ago, so he knows. Next, we did some special right triangles. One that's always asked for is a 30, 60, 90. And if you remember on that, whatever the hypotenuse is, half of it is the height. If this is the hypotenuse, the height is always half. There's a 2-to-1 ratio there. So it says the hypotenuse is 18 inches. Okay. This is 18 inches. That makes this height 9. Says what is the area? Uh-oh. I better remember the rest of that. I don't have the base. The base is always the height, in this case is 9, and square root of 3. All these special right triangles have square roots in them. This one's easy. 30, 60, 90. They all have 3's in common. Well, I need to answer the question. So area equals 1/2 base times height. 1/2. Here's my base. It's always whatever the height is times the square root of 3. And the height is always half the hypotenuse. And you say, well, why is that true? No one asked why, but it's Pythagorean theorem. If I square this and square this, the sum will be 18, the square root of 18. Well, I still don't have the answer, so here I probably go to a calculator. I take half of 9 times the square root of 3 times 9. And that area is approximately 46.7. That's approximate. I always put a dot over the equals when it's approximate, round all square units. Special right triangles. One of them that always comes up is 30, 60, 90, and it's a 2-to-1 ratio. If I erase the numbers, in other words, say this is 20, this would be 10, and this would be 10 square root of 3. That ratio won't break with the 30, 60, 90. Hope you remember that one. Questions there? What is the area? Well, first off, man, there's all kinds of area equations. What is that? Do you recognize it as a circle? The characteristics of a circle, there's 2 squared terms, and they're always balanced. This one has an x squared and it has a y squared, so it has to be a circle. I think I'm going to look at this one on the x and y axis. I'm going to see if it makes sense. That's what I like about geometry. Physically, it has to work out and make sense. Let's answer the question and see if it really looks like that. The equation that we had is this right here. And let's go to that coordinate system. Okay, looking at this, there's no number here, so it must be a 0 and 3. So at 0, 3 is the center. 0 here, change the sign here, 3. Square root of 144 is 12. Wow. So I'm going to go 12, 12, 12, 12. Out 12 again, 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 and again. So there's my circle. Rough-handed, free-handed. It looks something like this. Now what I notice on this, on the coordinate system, this is 10 by 10, or 100 square units. This one's 100, this one's 100, and this one's 100. So it looks to me like when I find the area of this circle that it's going to be more than 400, or somewhere around 400. That's what the logic of the graph looks like. Well, let's see if we can do it. Back from middle school, the equation for area of a circle equals pi times radius squared. That equals pi times 12 squared. That was the radius. Square root of 144 is 12. So that's 144 times 3.14 approximately. I'm going to let the calculator handle that. So I have 144. And if you use the calculator, pi is right below the clear key. And it says it's 452.4. I've rounded off. That's approximate. Man, that makes sense. I knew it had to be over 400. And the coordinate system, the physical look of it has to come out exactly. And that's what I like about geometry when you put it with the coordinate system. It makes sense. Looks like it actually works. Questions about that one? Okay. Number 6, put in slope-intercept form. Well, slope-intercept form would be y equals slope times x plus b. And I would expect the green bullets to be numbers and for y to be by itself. Well, let's do that with this one right here. The first thing I'm going to do is put 2x on the other side by subtraction. So I have 3y equals a minus 2x. You change sides, you change signs. Then I'm going to divide everything by 3. Three over 3 is 1y, that's what I wanted, equals a minus 2/3 of x plus 5. So in the slope-intercept form, there's the correct answer. And it's helpful for several reasons. We always want y equals so we can use the calculator to graph if we wanted to, but it's what you see is what you get. Once you get it here, I know it starts at 0.5, and I know it goes down to and over 3. It's hard for me to look at this and not see the graph. It's just like this. 1 plus 2. Don't think the answer. How do you not think 3? And once you get familiar enough with this, with y equals, man, I see the graph. On the x and y axis, it starts here and it has a negative slope that looks something like this. So that's the whole idea there. Questions on 6? Questions on 6? What is the distance between these 2 points? Well, it gives it to me in coordinates, okay? 5, -1, that's supposed to be a comma. 5, -1, and 8, 7. I think I'm going to go to the coordinate system again to see if it makes sense, if it actually works. Distance between points. Okay. I'm going to plot those points and draw a line between them. The distance between 5, -1, 1, 2, 3, 4, 5, negative 1. There's 5, negative 1, and 8, 7. 8, 7. And wants to know what is the distance of that. Well, on the coordinate system, if I look at it, 1, 2, 3, 4, 5, 6, 7, 8. My guess is it's somewhere in between 8 and 9, or it looks like it's right on 8 to me, but somewhere between 7 and 9. That's physically what this says, and I'm going to do the equation, but somewhere in there should be my answer. If not, I want to know why, because I plotted the points and I've looked at it physically on the coordinate system. The distance formula equals x minus x squared, y minus y squared. Take the square root. It's really another use of the Pythagorean theorem. A squared plus b squared equals c squared. In this case, take the square root, gets rid of the square. Okay, x minus x. 5 minus 8 is negative 3. Squared is 9. Plus y minus y. Minus 1 minus 7 is negative 8. Negative 8 squared is 64. I add those two together and that gives me 73. I want to take the square root of 73 and see if that makes sense. Square root of 73 is the exact answer, and the approximate answer, square root of 73, is around 8.54. Wow, it really looks like what it should. 8.5 units thereabouts the distance. The exact answer is the square root of 73. Questions about that? If you haven't noticed, we did a lot on the coordinate system. It's a very common thing in mathematics in our society and technical reading. The coordinate system is just embedded in everything, it looks like. Is there a question about 7? Number 8. Which lines are parallel? Which lines are parallel? Well, you could graph them all, but it has to do with slope. If slopes are equal, then lines are parallel. That's a theorem, a truth, something that always works out. So I'm going to look at the slope of each of these. The first one, y equals what you see is what you get. Slope equals 2. Oh, this one's not y equals. If I rearrange it, I get y equals minus 2x plus 8. So the slope equals negative 2. And on the last one, they're out of order, but it doesn't matter. I can still see if it's y equals what's with the x. Slope equals negative 2. So without graphing it, I can tell this line is parallel to this line, just by looking at the slopes. Now, if the slopes are not equal, they intersect. And that's a trig question. In other words, what if a slope is 2 and the other one is 3/2? What's the angle that they intersect at? Well, take the trig from Mrs. Jacket 9. We'll explain that. Right now, the only one they want to know is parallel. Parallel. And the answer here were the last two. Questions there? Number 9, in the drawing. Oh, now we have a physical drawing. 4 is 120 degrees. Well, that looks like it could be 120 degrees. It looks reasonable. So what is the measure of angle 1? And what is x? It asks both questions. Well, let's see if I understand the relationship. 4 would be the same as this, a vertical angle. This angle here, which is not numbered, would be the same as this alternate interior angle. And it's the same as 1. So the answer here appears to be that angle 1 is also 120 degrees, and it looks like it. Well, if 1 is 120 degrees, that leaves me 60 degrees for this right here. So 3x minus 12 has to equal 60 degrees. Let's solve that algebraic equation. Add 12 to both sides. Add 12 here. Add 12 here. Let's divide by 3. X equals 3 into 7 goes 2. 12, 4, x is 24. And that's a very common thing they do as well. That technology of angles, I don't know if you've ever thought about history, but it's kind of strange that England, I want you to think of England, is a small island in the European nation, the European continent. They ruled the world for over 250 years. Very small, the population, they did it with technology. They did it with angles and measurement. They were the first to figure out how to sail across the Atlantic Ocean and be within 50 yards of where they thought they would be. They were the first to figure, and they didn't share it with other countries. And that allowed them to move troops at will. What finally got to them in the technology, their ships were built out of wood and they ran out of wood. And so the other countries wouldn't share with them because they weren't very sharing nations at the time. This technology is used in a lot of things. They did it with stars and the sun and the sextant and a clock that didn't lose more than 10 seconds in 2 years. And that was history about 400 years ago. It's interesting. You ought to read it sometime. Well, let's look at what else we have here. Solve by using the quadratic formula. A, B, C. This is one formula they would expect you to know on the ACT Union test. If I'm solving the quadratic with a quadratic formula, it is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Brad, say something so I'll make sure I can hear.
Polo.
Oh, can't hear. Give me a second.
Uh-oh.
Try it again, Brad.
Polo.
Thank you. Okay, so if I'm solving this one, it is the opposite of b, which is 5. 2 answers, plus or minus. The square root of b squared, negative 5 squared is 25. Subtract 4, always the number 4, times a, in this case, which is 1, times c, which is 14. And it's a negative 14, so this goes to plus, all over 2a. 2 times 1 is 2. Now that's the answer, but nearly always they expect you to do the arithmetic, so let's do that. 4 times 1 is 4. 4 times 14, 4 times 4 is 16, carry my 1, 56, plus 25 is 81, so I have 5 plus or minus the square root of 81 over 2. Well, 81 is a perfect square, so I have 2 answers, 5 plus 9 over 2, and 5 minus 9 over 2. If you use the plus, 14 over 2 is 7. If you use the minus, negative 4 over 2 is negative 2. Both answers work in that quadratic. There's many other ways you could have factored this. You could have completed the square. You could have graphed it. But the quadratic formula, this always will keep coming up again and again and again. Quadratic formula. We had some problems on that. So hope that's familiar. There's a question there. And the last one, what is the midpoint between those two? The midpoint you're just averaging, and it's x plus x over 2, which would be 15 plus 3 over 2. 18 over 2 is 9. So the midpoint is 9, comma, then it's y plus y over 2. I'm averaging again, so that's negative 2 plus 8 over 2. 8 minus 2 is 6 over 2, and that's 3. And again, I might go to the coordinate system and plot those and see that that makes sense, 9, 3. I want to take a look at that in the coordinate system. I'm just going to make a rough sketch. 15, negative 2 is right in here somewhere. 3, 8. It's maybe right here. So I'm looking at this line segment and it says that middle point, could it be 9, 3? Sure could. That looks very reasonable to me. So those are all examples I wanted to see. So now let's go to the classwork and work those that you have questions on now. And if you don't have a question, I'll give you the answer. But if you have a question, I'll speak up. Brad, say something. I want to make sure I'm okay before I go into this next section.
Polo.
Thank you. Okay. This is the classwork for today. The homework parallels that. What is the slope-intercept form of this line? Would anybody like to see me work that? Anybody need to see that work? Okay.
They're shaking their head yes.
If you have, I can't see everyone on my screen. I got it set to see 4 of you, so it's the first 4 that log in. So if you want me to work it, unmute yourself and says, hey, Mr. B, stop and work it out. I would divide everything by 5. Divide by 5. Divide by 5. Divide by 5. So the slope intercept, I believe the answer is B. Answer is B. Look at number 2. Look at number 2. Anybody want to see that worked? Is that a yes, Eve? Okay. Are they completed squares? Yes, they're completed squares. If not, we'd have to complete the squares. And you always change the sign, so the center's at negative 6 and positive 1. Radius is the square root of 16, which is 4. The answer is C. Now, if that wasn't a completed square, that makes it a lot harder problem. But right now, they're all being completed squares. What about number 3? Want to see it? Anybody have a question on 3? Okay. Area of a right triangle. That must be the hypotenuse. So I'm going to draw it. I'm going to see what the geometry looks like. 12, 5, 13. So area equals 1/2 of 12 times 5. Half of 12 is 6. 6 times 5 is 30 units squared. Do I have 30? Sure do. A is the answer. Number 4, I'm going to go ahead and work it because that one you need to see examples of. By the way, there are many spatial right triangles. This is one of the most common ones you see, 30, 60, 90. It says the hypotenuse is 14. So I'm going to draw this 30, 60, 90 triangle. That is 14. The small side is half of that always, 7 on the 30, 60, 90. In other words, this is 30 degrees. This is 60 degrees. This side is 7 square root of 3. So the area equals 1/2 the base times the height. And at that point, I'd get out the calculator and start multiplying out. And they've been rounded off slightly, but the one that's on it is D. 2-to-1 ratio, 2-to-1 ratio, half, half. And then the half part times the square root of 3. That's from the Pythagorean theorem. 30 seconds. All of you do 5 on your own. Do 5 on your own without me telling you. You got 30 seconds. I know you can do it. What is the approximate area of this circle? Okay, let's see if we agree. Area equals pi times radius squared. It's completed squared, so I know that's the radius squared, so the radius is 100, so I have pi times 10 squared, which is going to be 100, times pi. Pi is 314. The approximate answer rounded off to the nearest whole unit is 314 square units. Now, if I wanted to, I could put that in a coordinate system like I did a while ago. The center is a negative 11, 5, and then I go out 10 and see, does it match 314? And see that it did. Questions there? Answer's D. Number 6. What is the slope-intercept form of this line? How would you do it? What would be the first thing you do? Answer that in your head right now. If I want to take this to the slope-intercept form of the line, what's the first thing I would do? Got your answer? I'd subtract the 12x. So I'd say 6y equals a minus 12x plus 6. On slope-intercept, y-intercept, I always want y equals. What would you do next? What would you do next? Divide by 6. Divide by 6. Divide by 6. So the slope, what you see is what you get is negative 2. And the intercept is 1. So multiple choice C is the answer. Well, about 10 minutes ago, we did 7. Let's see if you can do that one. What is the approximate distance between the 2 points? Take 30 seconds and see if you can do that. It really comes from the Pythagorean theorem. Well, it's x squared, y squared. You subtract the difference. Let's see if we can do that. From 0 to negative 5 is 5. From 8 to negative 3 is 11. That's 25, 121. And so I have the square root of 146. 144 is perfect square 12. The only one that makes sense is C. And if I wasn't sure, I'd get the calculator out and try the square root of 146. It's got to be C. C is the closest answer. Try 8 on your own. Take a minute and see if you can do 8. Which 2 lines are parallel? Are there any parallel lines? It has to do with slope. Well, let's see if we agree or not. Slope of this line, 1. Slope of this line, bring the x over, -1. Slope of this line, 2 into 4 is 2. Slope of this line is 2. C and D. The answer is B on 8. B. Then parallel lines. It says, given that lines A and B are parallel and the measure of angle 3 is 50 degrees. Something like 50 degrees right in it. So then the measure of angle 1 will be what? Select all that apply, angle 1. Well, let's see here. If that's 50, all interior are congruent, that's 50. And those are a linear pair, so 1 is 130 degrees. Is there 130 degrees? Be more than 50. I think that's the only one that works, isn't it? Number 9. C is the only one. And the last one, it says, again, using the same drawing, what is the value of x? Well, the equation, this is angle 4, and it's 130 degrees, and it equals 3x plus 10. Subtract 10 from both sides. 120 equals 3x. Divide both sides by 3. X equals 40. D is the answer on 10. And the last 3. Which line is the steepest? Well, that's a slope question. Slope here is 5, -5. Boy, that's a steep line. Oh, the slope here, remember y equals the horizontal line, so the slope's 0, very flat line. Here it's y equals the slope's -6, really steep line. And this one, the slope is a -1/2. It's really flat line. It looks like the steepest line is C6. And it wouldn't matter whether it was a -6 or a +6. They both have the same steepness, just going in the opposite direction. C is the answer. Number 12, quadratic formula to solve this. It equals 0. And by the way, on the quadratic formula, it has to equal 0. That's important. But it does, so I have my ABC, so it's the opposite of B. 2 answers, one's plus, one's minus. B squared, 3 times 3 is 9, minus 4 times A times C, which is 4. Again, that changes that back to plus, all over 2A. 4 times 4 is 16, times 1 is 16, plus 9 is 25. Square root of 25 is 5, so I have 3 plus 5 over 2, or I have 3 minus 5 over 2. If you do the plus, it's 4. If I do the minus, it's -1. Someone got into an argument and said, you made a mistake, Mr. B. It's not 1 or -1 and 4. All I'd have to do if we're in an argument is plug it back in. So if I want to check this answer, 4 squared is 16. 3 times 4 is 12. Minus 4, and it looks like I made a mistake. 8 over 2, opposite B, B squared minus 4, AC. That's a minus, that's a minus, that's a minus. Right here, that changes the answer. If you wonder why I was silent, this did not work. That does not equal 0. Okay? If we get into an argument, you put it in and it has to work. So what I missed or what I didn't put down is the opposite of 3. If you do the -3, that's 1. Do a -3 here, that's a -4. If I put a -4 in, it's still 16, but it's -12, -4. Oh yeah, that equals 0. So it's not a bad idea to check their answers. Daniel, I made that mistake on purpose just to show them they should check their answers. Brad, do you think anybody bought that?
Questionable.
Brad's had it before. Check your answers is always a good thing to do. The last one, the midpoint, you average. 11 plus 1 is 12 over 2. Average the y's. -7 to 7 is nothing over 2, which is nothing. So the midpoint is 6, 0, which is C. And up here, 1, -4, C would have been the right answer. Questions from anyone? Anybody have questions? Yes, Eve, go ahead.
For the quadratic formula, because if like A or C is negative, it makes the equation like the plus the negative or
Yes.
minus positive. If A and C were negative, would it stay positive?
Yes. And if you notice, if you see this right here when I'm moving, I always do it real big because I was taught to make sure you make it overemphasize so you know that I did it. Something had to change it. So if something's wrong, I can go back and change it. I said, well, it should have been minus. Why did I make that plus with minus? So if they're both positive, it's negative. If they're both negative, it changes back to positive, or it stays negative. If they're both positive, it's negative. If they're both negative, it's going to be negative. So it's kind of confusing. I do this just so I know that I changed it. And the reason I changed it, one of them was negative. When only one is negative, it goes back to plus. And that's the reason I check. It's a good thing I checked my answers here. I would have had the wrong answers.
So just to be clear, if one of them is negative, it's positive.
And you'll see me do this.
Right. Okay.
I do it big so I know I changed it for a reason. That way, if I check it, when I go back and check, I say, well, I did that. Was one of them negative? Oh, yeah, the C was negative. And it doesn't matter. Say it was -4 plus x squared. The A is still 1. It ought to be in this order, but many times they're not. And if it didn't equal 0, say it equals 8, I would have subtracted 8 and made that a -12. So everything has to be in place. And it takes a little practice. That's why I put them on there. Good question, Eve. Any others? Beth, you have anything?
Nope, I think I'm good.
John, Daniel, boss, you have anything to say? Brad,
Not at all.
thank you for helping me today.
Sure.
Brought back old memories, didn't it?
Oh, yeah.
Well, I'm going to say goodbye to everybody. When we do these, try to do your work within the next 4 to 36 hours, that day or the next day, while it's fresh in your mind. You'll find the homework parallels this exactly and get into Beth. Beth, thank you for everything. Hey, Beth.
Here it comes.
Yes, sir.
What's tomorrow?
Say it again.
What day is tomorrow?
Friday.
Oh, man, I'm glad I'm not a potato. I would hate tomorrow.
Put a spin on it.
Liz liked that one. Did you see Liz's face?
I smiled on that one. Eve almost smiled. I saw you, Eve. You wanted to smile and see potatoes hate fried. Never mind. I'm going to end it for everybody, and I'll see you in a week. Bye, Beth. Bye, everybody.